So there's a subtle distinction here then. So I'm using Crossplane as an organization, and I'm a developer that's writing to Crossplane directly, as opposed to I'm making a tool I want some developer to use, and I might use Crossplane to help me build that tool that then I hand to the developer.
Yeah, so I'd say both of those things are actually correct, and maybe
Okay.
and maybe we should get into how Crossplane is actually architected and its relationship with Kubernetes, if y'all are interested in going down that road.
Yeah, I think that's probably an appropriate time to bring in, okay, what's actually in this thing?
Yeah.
So far, it's a magic black box that abstracts components. So let's dig into what's actually in that magic box.
Yeah, absolutely. So I'll start off with kind of a very brief summary of how Kubernetes works in terms of its extension mechanisms, because I know the audience of this podcast is some sophisticated folks that are already aware of many of these things. But essentially, Kubernetes, you're likely familiar with it as a container orchestration platform or framework. So it exposes things like pods and deployments, right, that basically make it easier to put workloads across, a set of nodes, and manage those as kind of a single operating system. So that was the initial impetus for creating Kubernetes. However, all these different APIs like pods, deployment services that abstract things like processes essentially on a machine or some sort of networking primitive or that sort of thing. They realized that those primitives are useful, but there are many other ones that could fit into the same kind of system. So I think in the blog post that you were referencing earlier, I refer to Kubernetes not as a container orchestrator, but as a distributed systems framework. So it's kind of evolved to this point where it goes beyond those workloads.
Yeah, we had Kelsey Hightower on the podcast. Oh, geez, that was almost a year ago now, I think. And he brought up something very similar where, yes, Kubernetes is ostensibly there to schedule containers, but really there's so much more to it than that. It can be a platform for you to schedule just about anything, and it's extensible. So it sounds like that's what Crossplane is taking advantage of.
That's exactly right. And definitely take whatever Kelsey Hightower said and use that instead of whatever I provide here. But it's the same idea, right? And the way it does this is Kubernetes has an API server where these different abstractions, if you will, are represented as objects. So you may have heard of the Kubernetes resource model, which is basically a way of defining APIs that have a spec and a status. So the spec is the desired state, the status is the current state. And then there's a set of reconciliation loops that are frequently packaged into deployments called controllers that are essentially constantly driving that spec or driving that status to meet that spec, right? So we want the current state and the desired state to look the same. So that works, with workloads and services and that sort of thing. But it also works with other things. So Crossplane's kind of innovation in the beginning, right, was to represent these cloud provider infrastructure resources as objects in the Kubernetes API, which becomes really useful for a number of reasons. And this is kind of the base layer of how Crossplane works. These different providers, which are the backends for Crossplane, they say will represent all of AWS's resource types in the Kubernetes API, which means that we can have the information that's encompassed about their status, and that can be referenced from things like a workload that's running, right? So if you have your database and your workload represented in the same API, then you can start to have a lot of synergies between referencing information, about that database and consuming that from a workload.
Okay, so you're representing the AWS RDS instance using, is it a custom resource definition? Is that essentially you're creating one of those and then you have a controller that makes sure that RDS matches the desired state? Is that basically what you're implementing?
That's exactly correct. So a provider in Crossplane parlance is a set of CRDs and controllers to reconcile them that get installed as a bundle.
There are a lot of resources in AWS. I mean, like a lot. So is there an impact to having that many CRDs in a single Kubernetes cluster? Would you load the whole provider, or can you be more specific than that? Say, I only want, the database related ones or something.
Well, you can be more specific than that. Right now, the way the kind of like canonical Crossplane community maintained AWS provider works is it brings all of those resources, which is quite a number of CRDs and controllers. However, there is some nice caching and things like that to make sure that it doesn't create a lot of overhead to have a bunch of CRDs you're not using there. However, you could very easily, and anyone can go and write their own provider, or they could, break pieces off of the AWS provider, install that as more granular pieces. And at some point in the future, Crossplane actually has a package manager that installs all of these things. And at some point in the future, we may add to that package manager the ability to say, I just want this set of CRDs from this provider, just to make the interface a little better, so you don't have, API sprawl within your cluster.